Alright, welcome everybody to another quick update, and this will be the update on the significant tornado outbreak on Friday. And this was something that I was awake for and didn't put any forecasts for. It did become a moderate risk within a large region of the Midwest and the Ozarks region, and so it definitely did become a very significant outbreak. The NWS has already called it the Pi Day outbreak, and it's really a very prolific outbreak, very demonstrative of, I believe, the 1912 outbreak within Missouri that produced multiple violent tornadoes in a very close, compact region. And so one of the things on visible, like satellite, you can see there's multiple and a huge supercellular arc, and that outbreak really justified through that arc. And what we saw on a large scale was this very significant weather pattern where you had a ski jump trough ejecting into the Midwest and the Ozarks region with a very significant, favourable wind vector direction from the initiating boundary that produced this line of supercells that really were long tracked in a very favourable kinematic and thermodynamic profile. And so this is specifically an update on the Cave City EF3 tornado. And so just looking at this from currently, it has already been rated EF3 with, I believe, 165 mph winds, high-end EF3. I don't think they're going to be doing any adjustments on this tornado in particular, so it will be a very significant tornado, just like the Little Rock tornado, except this is very different to the Little Rock tornado. This was a well-defined classic supercell with a relatively small tight hook echo that persisted for a very long period of time in this long track type of profile, where you've got this strength and very large hodographs with a little bit of a weakening back sort of winds within the mid levels, slight weakening, and you've got this large sort of upper level outflow that really allowed for this favourable the favourable setup for the supercell to become long tracked. And so 81.77 miles in total length, so a very long track tornado, and a 700 yards wide, so almost what could be considered a wedge tornado at this point, because it's almost half a mile wide. So it's a very significant tornado that produced very significant damage, and we look at the damage as well. So with this is the radar imagery that we can have as of this is the lowest elevation, and clearly you can see immediately the reflectivity does not demonstrate a supercell, but actually it is. What is essentially happening is you see these pixels are very vertical oriented, and that's because of how far the radar is actually located from the supercell. And so there's a bit of a radar hole in the sense that the resolution of data is very low relative to what it could be with up close to the WSR 88D radars. And so this one's scanning relatively high in the air, even at the lowest elevation, and we're still looking at very significant velocities at this upper level. And this is just it's probably looking very high into the upper level part of the mesocyclone structure, so it may not necessarily indicate where the strongest winds, even whether the mesocyclone are, because it's slightly going over with this tilt. But again, near Cave City, we can see that this tornado was moving due northeast in that direction. And so this is some of the damages that we have. I think we'll just discuss the images one by one. So with this, we're going to be looking at the damage. So this is one of the high-end DIs that have been associated. In this one in particular, I believe, I don't quite remember the wind speeds, but this is an EF3 DIs with this one as well. And there is a clear debris everywhere almost. You've got some of these buildings behind that are fairly intact, pretty well built, as you can tell by some of the structure, and the brick walls reinforced with these pillars, and the material itself is relatively, well, I'd say very well built actually. But then you've got some of these debarking of these trees the backside, but you've got this region, particularly out here, to where it got significantly damaged and a lot of debris, and this shows the very violent nature of a core of a tornado. The dynamic piping of a tornado is very significant, because when you have this vorticity that's going down to the surface, it's very chaotic and very turbulent, so any debris can be ejected around the tornado, and from any because the tornado is racing cyclonically, it's going to push the debris from the southern part of the tornado core itself all the way to the northern side, and it's got this sort of cyclonic debris ejection, and you can see how all the debris has really compacted and ejected all into a specific region, and that's where anyone in this path of the tornado will be in very serious danger if they're not getting cover. So again, another image as well here demonstrating that as well. And this is the large-scale image that we're looking at for the supercells. You can see the very significant line. This is actually a dry line setup, again, where you've got this sort of north-south oriented, very east projected dry line, but that is pushed along with the surface low that moved through the Ozarks region, deepens very significantly into the 970s. A very significant anomalous pressure observed for this March period relative to other years and other analogues. So with this, you've got this sort of favourable pattern with the large scale oscillations and the different type of large atmosphere ENSO pattern. It's actually favoured this sort of Midwest significant hotspot that we've discussed previously for significant severe weather, and this is a perfect demonstration of that. You've got these dry lines that are pushing very far east into the Ozarks, as you would not typically associate. Last year we saw these dry lines that really pushed into the central plains, and now you've got this different setup now that's allowed for this to occur. And you can see clearly this isolated convection in a very long string all the way from southern Missouri all the way down to central Arkansas, and most of them are tornado warned. In fact, most of them are PDS tornado warned, and I believe one of the ones in the middle here are the Cave City Arkansas tornado. And the last thing is the debris itself. So you've got the very significant grounds, you've got some ground scouring, and you've got some debarking, and you've got the very significant debris being pulverized, because you can see the clear path where the tornado took. You can see how weak it was relatively in this part to the southwest of the town of Cave City, and then very significant damage, and then very probably peak intensities leaving the town, and then some debarking of the trees itself in the northeast part of the town itself. And overall, this is just one demonstration of all the multiple significant tornadoes that are still being rated and upgraded due to the NWS putting surveys. And what they're doing with these surveys is they're looking at different buildings, different points, and they're using this sort of almost checklist to say which is the Enhanced Fujita scale rating system. They're looking at these different DODs, and these different DODs are corresponding with certain DIs, and those DIs get a rating that correlate to a certain wind speed. And so the winds, you might get confused sometimes when you hear a DI being associated. So 165 mile per hour DI is the maximum damage that they've been able to observe, and they've managed to observe a maximum wind speed of 165 miles per hour. And that's just a minimum, because that's the maximum that they could observe, but the minimum to what the actual intensity could actually be, because the wind speeds have been at least that to take down the building, and even greater. And with some study and research, often when towns impacted like this with significant tornadoes, the actual intensity can be almost as high as 1.5 EF scales to the actual damage itself. So really the tornado could have had any sort of instantaneous velocities much higher into potentially the 200 mile per hour range. That is not really certain because of the low resolution nature of the data, but that's something that the research has suggested with multiple different surveyed tornadoes in the past, whether the relationship between the DIs and the actual intensity. So I'm really interested in that element, and seeing in the future how we can change the EF scale potentially to see how we can put out the actual intensities, because I do believe a more accurate way of measuring tornadoes is through the radar data, implementing more radar data and DAO data, where you've got these observations of the wind velocities and you do calculations using Werman's data and theories of how wind observations from aloft and near surface winds as well. And with the debris ball, you can also suggest with how high the debris has been ejected into the air and being pushed aloft due to the strong updraft within the center of the tornado. And with that, you can observe, as long as you have a V rod and you have that observation, you can get an idea of a strong to violent tornado, and then you can put a bit more detail into the actual observations and the intensities. So with that, I think I'm going to leave that as the final discussion of this tornado. This is the Cave City EF3 tornado, and we'll be discussing the other tornadoes of this outbreak as well. Alright, see you guys next update.